Good afternoon, class. This is teacher Hiria Bulova Richard, going to teach Pythagoras theorem using Geogebra. Okay, that is what we call Geogebra. On this tool, if you are to deal with the Pythagoras theorem, you need this icon of the angle and the icon for the polygon. How do you begin? Start by selecting polygon. The polygon you are going to apply in this concept is what we call a right-angled triangle. So come to any of the squares, identify and choose any vertex. I've chosen that one and my vertex is already labeled A. You can now drag excuse me. Let me start afresh. Okay, go to polygon, choose triangle, come in the Geogebra, identify any vertex, click to establish the beginning point, which is point A, then you drag downwards to a point or a vertex of your choice. For me, I will opt to use that one. Click to establish the point, then drag to the right to meet the line from the upper point, which is point A. Click that and then join point C to point A. The polygon you will come up with is what we call a right-angled triangle. Now this triangle, when you look at it, it has already three sides labeled A, B, C. How do we call this side? This side is called the base, the height, and the hypotenuse. Our major concern is to handle Pythagoras using that. So what do? You now go to the second icon, which is this one. This very one. Select regular polygon. Then come at point A and click at that point. Drag through line B, which is your height, up to point C. After reaching there, you click. There is already a template of 4 coming. Just click OK. And you will have a square formed along the height. Do the same from point C. Remember, we are doing it together. Drag through the base to point B. When you reach point B, click. You get still a template of 4. Click OK. You will get another square drawn for you along the base. Now go to the hypotenuse. Click at point B, then drag through the hypotenuse to point A. Then click OK. So you have your 3 squares along each of the sides of your triangle. But we are interested in knowing the relationship between those 3 squares. So how can we quickly establish the relationship? Let's check the area of each and see whether we shall establish any relationship amongst them. So you now go to the second icon of the angle. This time, since you want area, select area. And now, go and click in every shape. You'll get that area. Click there. Get that area. Click there. Get that area. We see that the area of this square is 25, the one on the hypotenuse. This one is 16, and this one is 9. Do we have any relationship we see between this area, and this area? The answer is yes. What's the relationship? You realize that when you add 9 to 16, you get 25. And that's the proof of Pythagoras theorem. Now we are having an activity that we are going with. Okay, I will send the activity, but the activity was supposed to be, you are going now to practice working out the Pythagoras theorem of a right-angled triangle with 8 squares along the height and 6 squares along the base. Thank you very much for listening.